everyone, let's get started on our first video together. So when you open up a video, the very first thing you're going to see is this page here where it tells us which module and which lesson we're on. So on this one here being module 1, lesson 1, I call this 1.1. We are going to be verifying solutions of linear equations. Now in today's video, I'm going to talk about what I gave you. I normally won't talk about that, but I want to talk about it so you know what you have in front of you and what I'm looking at, and they're exactly the same, okay? So the very first thing I gave you was that packet, and the very first page in that packet looks like this right here, where it says Module 1.1, writing equations and verifying solutions of linear equations. Right? So it also has our learning standard, our learning target, our learning goal right on top. What are we expected to do today? I can verify a real world problem with a linear equation in one variable. What's a variable? A variable is just a letter that represents an unknown value. So some number. They're saying, hey, if this is that number, what do you do with it? Well, we put that number back into the equation, and that's called substitution. So we're going to be looking at those numbers today and some substitution, okay? Also on this first page, I've drawn a pink box. This pink box is an example of an already completed problem that you can look at to see how they did it. What did they do? All right? We'll come back to that in just a little bit. Also on this first page, it says example 1. Anytime it says example, that's what I'm doing with you. Underneath where that example is where I want you to write any work or any notes that I do. Then on the back side of this paper, we have example 2. That is one that I'm going to do with you. Now we get down to where it says check your understanding. When you see check your understanding, that is something that I want you to try on your own. Okay? If you get stuck, put a question mark there. Write down what your question is, bring your question to class, and then we'll go over that. After check your understanding, then we have example 3. Okay? And then after we go over example 3, there's another check your understanding that I want you to try. Again, if you get stuck somewhere, put a question mark by it, and then bring it back to class and let's talk about it. Now at the very bottom of that back page, there's something that says exit ticket. Now, when you see this exit ticket, I want you to go ahead and leave that for class tomorrow. We are going to do that in class at the end of our lesson, okay? So just leave that one there. All right, let's go back to the front page. So turn back to the beginning of your packet. And let's talk about this example that I have highlighted here in the pink box. What is this? So the solution of a linear equation in one variable is a value that makes the equation true. This satisfies the equation. In other words, the solution is a value that can be used to replace the variable and make both sides of the equation true. So right here they give an example. 3x plus 5 equals negative 19. So they're saying that 3x plus 5 on the left side should equal negative 19. Then they're saying the answer that makes that true is negative 8. So they take the negative 8 and they replace the negative 8 into the equation. All right, so then underneath it says 3 times negative 8 plus 5, does it equal negative 19? 3 times negative 8 is negative 24. Negative 24 plus 5, does that equal negative 19? And the answer is yes, it does. Negative 19 on the left side is equal to the answer, negative 19 on the right side. So what does that mean? That means that negative 8 is a solution. So what we're trying to do is they're going to give us some solutions. We're going to substitute that solution back in for the variable and see if it's a true answer or not. Okay? All right, so keep looking right here at example 1, and I'm going to go ahead and jump over to my slides. Same problem. Okay? Here's our learning target again. Our learning target says that we can verify whether a given value is a solution of a real world problem modeled with a linear equation. Now in this class, we're going to see a few different types of equations. The one that we are looking at right now is this one here. it is called linear. Okay, linear has an x in it, has a variable x to the first power. Now this other example that I have here, we're not going to do just yet. We've got a little while to work on it. But this one is called quadratic. Anytime that it's quadratic, it's x to the second power. And this last one, if you notice, it has an x with an exponent of 3. That's x to the third power. That's called cubic. Okay? So the one that we're working with today is linear. All right? All right, so let's go ahead then and let's go on to example 1. And let's do this one together. So I'm going to go ahead and put 3 R's right over here. The reason that I put 3 R's is because my intention is to read this problem 3 times. The first time I read it, just to process what it's saying. The second time I read it, to listen for any clues. And the third time I read it is to make sure I know I answered what the question was asking. Okay? So the very first time I read it, Kevin buys 66 markers plus 5 packs of markers. Fernando buys 48 markers plus 8 packs of markers. Kevin and Fernando buy the same total number of markers. Write an equation to determine the number of markers in each pack. Kevin and Fernando says that there are 6 markers in each pack. Verify their answers. Okay, I've read it once. Now, Kevin buys 66 markers plus 5 packs of markers. Fernando buys 48 markers plus 8 packs of markers. Kevin and Fernando buy the same total number of markers. So they are going to be the same. Write an equation to determine the number of markers in each pack. Okay, so I have to write an equation. And then Kevin, and I'm looking for the number of markers. So now I know what I don't know. I don't know markers. That's what becomes my variable. So the variable I'm going to use is m. Again, you could use x, which is completely fine. Okay? In each pack, Kevin and Fernando say that there are 6 markers. So is that true? Verify their answer. All right, that was my second time reading it. Now, I'm going to go ahead and write my equation. So Fernando and Kevin have the same amount of markers. So Fernando and Kevin, or Kevin equals Fernando. Kevin has 66 markers plus 5 packs of markers. But we don't know how many markers are in each pack. Fernando has 48 markers plus 8 packs of markers. But we don't know how many are in each pack again. Okay? So now they're telling us, but hey, they say that there's 6 in each pack. So we have to check that. Okay, so if there's 6 markers in each pack, we are going to replace a pack of markers with the number 6. So I have 66 plus 5 times some number, 48 plus 8 times some number. Now, what is that number? Well, the number they're telling us is 6. They're saying that each pack of markers has 6. Are they correct or incorrect? So let's go ahead and look at that. So we're going to do the left side, and then we're going to do the right side. Now, if you have a calculator, you can use a calculator to simplify this. So 5 times 6 is 30. 30 plus 66 is 96. On the other side, I have 48 plus 8 times 6, which is also 48. So 48 plus 48 is 96. That is true. Okay. All right, so now I got to go back, read the question, because now I know it's true. But now I got to go back to read a question to make sure I answered it correctly. Kevin buys 66 markers plus 5 packs of markers. Got it. Fernando buys 48 markers plus 8 packs of markers. Okay. Kevin and Fernando buy the same total number of markers. Yep, that's why it's equal. Write an equation to determine the number of markers in each pack. Kevin and Fernando say there are 6 markers in each pack. Verify their answer. So we substituted in 6. And when we did that, we found that the left side of the equation and the right side are both 96. So that's true. So how do I write my answer? I'm going to write 6 markers are in each pack, because that's the value that we were checking. Okay? All right, now that was example 1. Let's go do example 2. Now to make this video just a little bit faster, I've gone ahead and I've written down my equations already, okay? So, but I'm still gonna do my 3 reads because I want to make sure that I practice that. So I'm gonna write down R, R, and R to make sure that I do read it 3 times. The first time is just to read it. A group of friends decides to go out of town to a championship football game. The group pays $185 per ticket, plus a one-time convenience fee of $15. They also each paid $27 to ride the tour bus to the game. If the group spent $2,771 in total, write an equation to determine the number of friends that go on the trip. Which of the following represents the number of friends on the trip? Okay, now let's read it again and highlight what's important. A group of friends decides to go out of town to the championship football game. Nothing there is important. The group pays $185 per ticket. Okay. How many tickets? I don't know. So that's what becomes our variable. X for tickets. Lost my lesson there. Okay, let me erase that. Our tickets is going to be X. So I don't know how many tickets they bought. Plus a one-time convenience fee of $15. They also have to pay, also means add, they also pay $27 to ride the tour bus to the game. If the group spent $2,771 in total, so that's what it's going to equal, write an equation to determine the number of friends that go on the trip. Which of the following represents the number of friends? Okay, so $185 times X for the number of tickets, plus $15 is a one-time fee, plus 27 times X, because the number of people had to pay for the bus. So X actually doesn't represent tickets. X doesn't represent bus rides. X actually represents the number of people, okay? So how many friends can go with us? 11 or 13? So in order to check that, we're going to replace the X with 11 the first time. So we're going to use substitution and substitute 11 wherever there was X. Now, when you plug in your calculator, we want to see if the left side equals 2,771. Okay, so now plugging this all into my calculator just as I see it, 185 times 11 plus 15 plus 27 times 11, that answer comes out to 2,347. Does that equal 2,771? Nope. It does not. So when it does not equal it, that means that A is not the answer. Okay? All right, we have to do it again. Now, if you're using a pencil and you're like, I don't want to rewrite all that again, that's okay. All you have to do is replace that 11. But this time, instead of 11, what are we going to substitute into the equation? Well, the other answer we have to check is 13. Now, when we substitute or plug this all into our calculator to see how it works out, okay, we're plugging in all of this, and we want to see if it comes out to 2,771. In this case, it does. So 2,771 does equal 2,771, which means 13 is our correct answer. Now, what is that talking about? That's talking about friends, right? So again, read that question the third time. A group of friends decides to go out of town to go to the football game. They pay $185 per ticket plus a one-time convenience fee. They pay $27 to ride the bus. And if the group spent 2,771 in total, determine the number of friends that can go on the trip. So our answer for this one is 13 friends. Okay? All right, I want you to pause the video and I want you to go check your understanding number 1. Then come back here and see if you've got the equation part right. Okay, go ahead. All right. Check your understanding number 1. Hopefully you got your equation right, but I did put the equation here for you to look at. You can compare that. If you have any corrections to make to the equation, go ahead and make those. So on this one here, hopefully you did your 3 reads. Okay, that's really important. The first time we read it is just to read it. The second time to highlight what's important. And the third time to make sure that we are answering the question correctly. So you already spent $21 on gas for your trip. You stop at a station planning to buy more gas at a cost of $4.20 per gallon. After pumping the gas, you also spend $8 on a car wash. If your total expense is $71, write an equation to determine how many gallons of gas did you buy. Which of the following is the number of gallons of gas purchased? All right, so what's important here? You already spent $21, so that's what you're going to start with. You stop at a station and you want to buy more, okay? So, and it costs $4.20 per gallon. That means $4.20 for each gallon you buy. After pumping the gas, you also, that's a plus word, spend $8 on a car wash. If your total expense is $71, write an equation to determine how many gallons. That's what we're looking for. We don't know. How many gallons of gas did you buy? So our variable on this one is gallons of gas. On this one, I'm going to go ahead and use G. But you can use X if you want to. Okay? So now that we have our equation, 21 gallon, or 21 that you had already spent, $4.20 per gallon, plus the $8 you spent on the car wash equals 71. Now, anywhere there's a G, we're going to replace G with 8. Okay? So we're going to put an 8 here. Now, I want to see if this left side, when I plug it in the calculator, equals 71. So 21 plus 4.20 times 8 plus 8, that one there is, let's see on that one. So 420 times 8, this one comes out to, I didn't measure that one. Oh, wait a minute. This is the one I want you to do on your own. And if you get stuck, you bring your questions into class on that one, okay? So I helped you through most of that one. Now go ahead and finish it, all right? If 8 doesn't work, check 10, check 12. All right, so now track your progress. How are you feeling right now? Can you write a linear equation? Can you verify with whether a given value is a solution of a real world problem? Let me know. All right, example number 3. On example number 3, I was given a budget. I was given a budget to pay $45 for the decorations and buy $3 party favors. The company called and asked me to triple the expenses since they tripled the number of guests. If my new total budget is $270, write an equation to represent the total budget for the party. How many party favors can you buy? Okay, what's important on my second read? I have a budget. I have to pay $45, so they gave me that. That's adding. And I have to buy $3 party favors. Now, because I don't know how many party favors I have to buy, that's my variable. I'm going to go ahead and put the variable F. Then the company called me and asked me to triple the expenses. If I triple something, I have to multiply it by 3 because they tripled the number of guests. If my new total budget is $270, write an equation to represent the total budget for the party. How many favors can I buy? That's what I'm looking for. How many party favors can we buy? Okay, so here's my equation. I have to do 45 plus 3 times F. And I did that. 45 plus 3 times F. Then they tripled it. So I have to multiply it by 3. And that should equal my total budget of $270. Now, on this one, they've given us 4 answers to check. So the first time, we are going to substitute 10 in where F was. Okay. I want to see if the left side equals 270. So 3 times 10 is 30. 30 plus 45 is 75. 75 times 3 is 225. Does that equal 270? Nope. So then that means A is not our answer. Okay? All right, now we have to do it again, but this time we're going to substitute in 15. So you have 2 options. You can rewrite it. Or you can erase the 10 and replace the 10 with 15. Now, when I combine the left side, it should equal 270. 3 times 15 is 45. 45 plus 45 is 90. And then 90 times 3 is 270 equals 270. And that's true. Okay. So I don't need to check C and D. If I wanted to, I could definitely go back and check C and D. Okay. So I have to read it a third time though, because yeah, it's right, but I don't know what you're asking me. So I was given a budget to pay $45 for decorations, buy $3 party favors. Then I had to triple it. My new total budget is $270. Okay, so what does the 15 mean? Write an equation to represent the total budget for the party. Okay, we did that. We solved it. How many party favors can I buy? Oh, that's what we were looking for. So we have 15 party favors. Okay, so now that we've got that, I want you to go on and check your understanding number 2. Now, if you get stuck, put a question mark by it, write down your question, and we can talk about those in class tomorrow. The last piece is, if you want to check your equation, here's your equation. Did you match that up? Did you get that right? Did you try it on your own? Lastly, track your progress. How do you feel after this video? I know there's still some confusion, but do you feel a little better? Did you write down your questions? Do you have questions for me? So on your learning target, I can verify whether a given value is a solution of a real-world problem modeled with a linear equation in one variable. If you feel that you're good at finding your variable and plugging your variable in, substituting it in to solve the equation, go ahead and highlight that. If you're not 100% sure, it's okay to wait, and we'll talk about that when you come to class tomorrow. Have a great evening.